Hello everyone, welcome back to the last video on the topic of trigonometric. So this is the basically a revision chapter where we will see what we have learned so far. So first of all, this is the phase 1 where we have understand what is a circle. Okay, so we understand this is a circle and there is some angle in the circle, that is 360 degree. Next, we have understand what is the unit to measuring this. So we have already know what is the degree, and we used to measure any angle in degree only. But we also know about we just learned that there is another unit that is called radian, and 360 degree is equal to 2 pi radian. Okay. So in circle we understand the arc length formula. Okay, so it's saying that if we have this center of the circle and we have any radius on the circumference of the circle, and if we take the equal length, means for example this is 1 centimeter and we also take 1 centimeter on circumference, and we join this with the center, then the angle this area is making on the center, this is this can be represented as a L, that is this area. Okay, L equal to R into theta. Okay, next we have understand the conversion. So unit flipping, how we can flip uh, degree to radian and radian to degree. Okay, so if we have anything given in radian and we have to convert it in a degree, so we can just make degree into pi by 180. For example, we have 360 degree, so we want to convert this in a radian, then we can multiply this with the pi by 180, right? So it will be 1836 equal to 2 pi. You see, I have already written it here, right? If we have some anything in radian and we want to convert in a degree, then we can multiply this radian into 180 by pi, opposite of this, right? Now the third thing, Pythagoras. Okay, so with Pythagoras we know, if we have a right angle triangle, this is right angle, and here we have theta, and this is a, b and c. So a square plus b square equal to AC square. It means the summation of uh, hypotenuse and base is equal to the root of the square of uh, so perpendicular, the square root of perpendicular and base addition of these both is equal to the square root of uh, hypotenuse, right? And we see, if we divide this with AB, 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 so AB square, AB square, AB square. So AB square is cancelled. This is BC by AB square, that is 1 plus BC by AB. So this is BC and this is AB, that is cot, right? Equal to AC by AB. This AC by AB, this is cosec. So you see, we got 1 plus cot square x equal to cosec x. Okay, if you will divide this with BC, you will get the another term, right? Next, the phase 2. Here we understand what is shifts and negative rules. Okay, so first of all we see the sign flip. Here negative angle rules. So if we have something cos minus x, then it will be cos x, and if we have sine minus x, then it will be minus sine x. So cos observe the sine minus sine, but sine cannot do that. If there is something any angle in minus, then it will be minus sine x. Okay. So cosine completely delete the negative sign. So cos, that is also called as a cosine, this completely delete the negative. Say no, I don't like negative things, please exclude this. You can understand like this. Now we have 90-degree shifts. So co-functions pi by 2. So if we have a graph here and this is 90 and this is 270, then sin pi by 2 minus x equal to cos x. Okay, so 9 by 2 minus x, then it will be in this quadrant. And if we see any, if we make any angle with respect of x y axis, okay, suppose this one or this one or this one, then this function will be changed. Okay, and what will be happen, sine will change in, sine will change in cos, and cos will change in sine, cosec will change in sec, and sec will change in cosec. Cot and tan are the very loyal for the each other. In every term you will see they convert into each other's form, right? So when we will change the function, it will be changed like this. If we have sine 90-degree minus x, it will be changed in cos. If we have cos 90-degree minus or plus x, then it will be changed in sine, and so on for the all two. Uh, Now uh, here 180-degree and 360-degree, so boundary shifts pi and 2 pi. So if we have sine pi minus x, it will be sin x, cos pi plus x equal to be minus cos x. We see what happened here. We see here uh, above that where it was, I think here. Okay, so we see here cos, when there is chance for cos, it observe the minus sign, you see here, right? But in this example it's not observing that. In this example you see sine pi minus x equal to sin x, okay, very good. Cos pi plus x, and here sine 2 pi minus x is minus sine, okay. Cos pi plus x is minus cos. So and it means that cos, if there is positive sign in cos, then it will be converting negative. Or is it means that sine minus x is means this is creating confusion, that sine pi minus x is only x, because we see here if there is any minus sign for the x, then it will be minus only. So I will tell you that here what happening. Let me just clear this so I can explain it to you. So here when we uh, shift the boundaries of pi and pi by 2, so here in the first quadrant all the trigonometric functions will be positive. Okay, so if we have any angle with respect of this 0, that is also 2 pi. Okay, and if we make any angle like sine pi by 2 minus 30, or theta or x, let's say it's x, then you see sine will be always positive in this first quadrant. So it will be, and it will be changed. Why? Because we are checking as no, so we are checking with respect of x, then it will be not changed. So we will get sine, and what is this, 30-degree, sine 30-degree, or sine x or sine theta, whatever you can say. Okay, so here the symbols here are decided on the basis of that if this conversion, uh, what the conversion we are doing for example sine cos, is it the location of its location is very important. So here you see sine pi minus, in this example you see if we have, if we have sine 2 pi or pi, anything we can consider. Suppose we are considering 2 pi minus x, so it comes in the, it comes in the 360, so it will come in this fourth quadrant, and in fourth quadrant sign will be negative, and because we are making this angle with respect of x axis, then sign will be as it is sine x. Okay, and if we have this relation with respect of y-axis, that is pi by 2 here, no, not pi by 2, actually 3 pi by 2, then we will see sine 3 pi by 2 minus x equal to, in this quadrant, in the, this is negative, no, 2 pi. Now suppose this is 3 pi by 2 minus x, so it will be in this quadrant, and now it will be, this sign will be changed in cos, and because in this quadrant only cot and tan is positive, then it will be minus cos and this x, cos x. Okay, so this is how it works. Phase 3, compound angle sum and difference. Okay, so you see sine split. So this is very important. Sine is friendly, it mix sine and cos and keep the uh, true sign. Plus says plus, it means that when we look at sine x plus y, then it mix sine x then cos x. Now cos have x here, then it will be put plus sign same as this, and now here we will start with cos x sine y, right? But and you see for the minus, sine x minus y sine x cos x minus cos x sine y, right? But this is not the same for the cosine, that is cos. You see, cosine is a selfish, it groups itself first and flip sign plus become minus, right? So your cos x plus y, so cos x cos y, they have covered their requirement. Now if there is plus, then it will be in minus, minus sin x sin y, right? Same for the minus sign cos, if we have cos, then cos then xy, then xy, and if it is minus, then it will be positive plus sin x cos y, right? Now fractions, tangent and cotangent. So tangent tan x plus y equal to tan x plus tan y. This is also lawyer like sine by 1 minus tan x tan y. So if we put the value of this sine and cos in the form of sine by tan equal to sine by cos, then you will get this answer. Okay, and same for the cot also, you have to put cos by sine x, right? Now the fourth thing, multiplier. Okay, the double and triple angles. So here you see we have sine 2x equal to 2 sine cos x, we have cos 2x equal to cos square x minus sine square x equal to 2 cos. You can also prove this. Okay, and we have already proved that, and this video is only for the uh, revision, and you know that what is your current position and how much you know about the trigonometry, because if you know the formula, then you have done the 50% work. So this is very important to check and understand, right? So tan 2x equal to tan x by 1 minus tan square x. Now triple size, so we have to do the triple size. For the triple size, sin 3x equal to sin 2x plus x, then you will get this, right? Now phase 5, sum to product and product to sum. We have to, if we have in sum, then we have to convert it in product. If we have in product, then we have to convert in sum. So what tools we are having? Sin x plus sin y equal to 2 sin x plus y by 2 cos x minus y by 2. Okay, so this is the this is used when we are converting something that is in positive in the sum, and we have to convert this in a product. There is so many questions out there in AC and NCERT also, where you will get confused what to do. Okay, so these formulas will be uh, very helpful at that time. Okay, so now we have in the very last time of this video, and this is the introduction. Technically it should be the in the first video, but I just want to keep all the interested candidate only, and I don't waste their time and my time also. So introduction, this is Aryabhat. He have a major contribution in the trigonometry. So it says that trigonometry is used in many area such as, so this trigonometry is in use, the actual application are there in so many areas, such that science of semo- seismology seismology, designing electric circuits, describing the state of an atom, predicting the height of tides and the ocean, analyzing a musical tone, and in a many other ways. So you see, this is very important, okay? And in all this, if you are very good in maths or trigonometry, then uh, you can go for this one, these descriptions, and you will get a good knowledge of that. Okay, so that is a very long series, I believe. And thank you so much everyone for being connected with me and to choose me to learn with me. So thank you so much, and great work. Cheer for yourself. Bye bye, happy learning, see you.